Example, you recently had a child. You want to begin saving for the child's college education. You think that she will need $150,000 in 17 years. You feel confident that you can earn 8% per year. How much do you need to invest today? Well, normally in real life, we would be saving money for things like education or maybe retirement or house purchase by setting aside something pretty regularly, not just once. That's what you will learn in chapter 6. Here in chapter 5, it's all about a single cash flow. So in this example, we just set aside one amount of money, just once. It will not be repeated in the future. We set aside $150,000. We wait 17 years. The money grows by 8% per year. How much do you need to invest today? Following the present value formula, we need to take the future value and divide it by 1 plus r with that sum raised to the power t. We plug in the numbers, $150,000 divided by 1 plus 8%, that sum is raised to the power 17. And the answer we get is $40,540.34. I think I may have made a mistake. Example, you recently had a child. You want to begin saving for the child's college education. You think that she will need $150,000 in 17 years. You feel confident that you can earn 8% per year. How much do you need to invest today? In real life, when we are saving for things like education or retirement or house purchase, we set aside money pretty regularly, maybe once a month, once every few months, once a year. In this problem, things are simplified. We are going to set aside just one amount of money, only once. It will not be repeated again. But whatever we set aside today, which is what we need to calculate, that will be earning interest over 17 years, 8% per year, and it has to grow to exactly 150,000. So what is the present value of $150,000? Following the present value formula, we take $150,000 and divide it by 1 plus 8% with the sum raised to the power 17. The answer we get is $40,540.34. In the financial calculator, you would do the following. Let's turn the calculator on. Let's clear everything. Second, plus, minus, enter. So I reset the calculator. Everything is back to all default values. 150,000 is our goal. That's what we want to have in the future at the end of 17 years. That's our future value. We set it to a negative number. We change the sign to minus. Press future value, FV key. Then we enter the rest of the information. The number of years is 17. I press 17N. And the interest rate is 8% per year. I press 8IY. Compute PV, 40,540.34. That's the answer I showed on my slide. Example, Mike needs $40,000 as a down payment for a house, which he plans to buy 6 years from now. He earns 2.5% on his savings. He can either deposit one lump sum amount today for this purpose, or he can wait 1 year and deposit a lump sum then. If he waits a year, would he need to deposit more than today or less than today? What do you think? Well, after 1 year, there'll be less time left until for the money to grow to 40,000. So probably he would need to deposit more, right, to make up for the lost year, for the lost 1 year worth of interest. So how much more would he need to deposit if he waits a year? Let's do it this way. If he deposits now, how much would that be? Present value. Calculate present value. You take 40,000 that would be needed in 6 years, and you divide it by 1 plus the interest rate of 2.5%, and that sum is raised to the power 6 for 6 years. The answer we get is $34,491.87. In the financial calculator, let me bring it up and put it right here. Let's clear everything. 40,000 is what we need in 6 years. I put 40,000. I change the sign to negative, and I press FV for future value. It will be needed in 6 years, 6N. And the deposit I will be making now will be earning a 2.5% interest every year. 2.5 IY. Compute present value. $34,491.87. Then let's think about how much Mike would need to deposit if he waits a year. It's kind of very similar. The only difference is there is 1 year less, right? So the only thing that changes in the calculations is the number of years. It's no longer 6, it's now 5. And we take $40,000 that will be needed for the house purchase and divide it by 1 plus 2.5% and the sum raised to the power 5. That gives, as expected, a higher deposit that would be required. $35,354.17. Let's verify it in the financial calculator. Turn on 40,000 negative future value. 5 is the right number of years to use, 5N. 2.5 is the interest per year, IY. Compute PV, $35,354.17. And now we can answer our question. If you wait a year, we would need to deposit $862.30 more. We could do the calculations differently. We could start with the deposit that we calculated first, if it's made today, and then simply find its future value after 1 year. So we take $34,491.87 and multiply it by, open parenthesis, 1 plus 0.025, close parenthesis. And that would give the same number we had earlier when we directly calculated the deposit if it's made 5 years prior to the house purchase, right? $35,354.17. I would probably say that this is a less intuitive way to calculate next year's deposit, but it's also correct. And in fact, in finance, in problems like what we are doing in chapter 5 and then later in chapter 6, with a bit more stuff going on, there's often going to be not 1 but 2 or 3 or even more solutions, perfectly correct solutions. a completely different approach to find the answer to the same problem.